In part 4 of our lesson on translations of sine and cosine, we're going to graph a sine function. It's CYU time, so pause the video, work the example on your own, then restart the video to check your answer. Okay, let's see how you did. So first order of business is to take our function equation and write it into the standard form. So this is going to be negative sine of 3 times the quantity x minus pi over 3 minus 2. Or you can write this as plus negative 2. It's always a good idea to check out your factoring and make sure that you did it correctly. So 3 times x would give us the 3x. 3 times pi over 3 would give us pi. And now we can go about finding all the attributes of the graph. We know that the period is equal to 2 pi over b. And in this case, we can see that b is equal to 3. So we have 2 pi over 3, and there's nothing to reduce here. So the entire cycle is going to take place in 2 pi over 3. So this will be a horizontal compression. The amplitude is the absolute value of a, and we can see here that a is equal to -1. So the absolute value of -1 is equal to 1. The phase shift is letter C. We know that letter C is the number that comes after the minus sign. So that's pi over 3, which is positive. So that means that the shift is to the right. The vertical shift is letter D. D is what comes after a plus sign, so D is -2, which means the graph will shift down. The domain of a sine function is all real numbers, so the domain will be -infinity to +infinity. And the range, we know that the range of sine starts out -1 to +1. It will be affected by the amplitude, which in this case is 1. So that's not going to change anything. So that's -1 to 1. And then it is affected by the vertical shift, which is -2. So we have to take each of those y values and move them down by 2. So -1 down by 2 becomes -3. +1 down by 2 becomes -1. So that's the range we expect to see on our graph. Next, we'll solve the inequality to find the shifted cycle. We know for sine and cosine, we have to take the argument of the function and put it in an inequality between 0 and 2 pi. We can use the factored or unfactored version of the argument. And remember, I've mentioned, I think your algebra is just a little bit easier if you use the unfactored form. So we'll put 0 is less than or equal to 3x minus pi is less than or equal to 2 pi. So we'll need to add pi to all three pieces. our inequality becomes pi is less than or equal to 3x is less than or equal to 3 pi. Next, we'll divide all three pieces by 3, and our inequality becomes pi over 3 is less than or equal to x is less than or equal to pi. So we know that means that our new shifted cycle of the graph is going to start at pi over 3 and it's going to end at pi. And we've learned that this is a good time to take the opportunity to check to see if this agrees with our period that we found earlier. So if we subtract the start from the end, we have pi minus pi over 3. And of course, this is 3 pi over 3. So when we subtract those, we get 2 pi over 3, which agrees with what we evaluated the period to be earlier. We're ready now to evaluate our 5 key points. We know we're starting at pi over 3 and ending at pi. To find the midpoint, we have to add up the start and the end and divide by 2. So if we take half of pi over 3 plus pi, now I know I'm going to want this with a common denominator here, so I'm going to go ahead and write that as 3 pi over 3. Same thing as pi. This becomes 1/2 of 4 pi over 3, which is 2 pi over 3. Next, we have to find the quarter point, so we find the average of the start and the mid, which means add them up and divide by 2. I like to multiply by 1/2 instead. So we have half of pi over 3 plus 2 pi over 3. So now we have 1/2 of 3 pi over 3, which is pi. Right? The 3's cancel. Half of pi is pi over 2. Now we have to find the 3/4 point by adding up the midpoint and the end point and dividing by 2. So we have 1/2 of 2 pi over 3 plus pi, which I'll write as 3 pi over 3. So this is 1/2 of 5 pi over 3, which is equal to 5 pi over 6. Looking at our denominators, we have a 3, a 2, and a 6. So our common denominator is going to be 6. So we want to write all of our x values with a denominator of 6 to make our graphing easier. Pi over 3 will be 2 pi over 6. Pi over 2 will be 3 pi over 6. 2 pi over 3 will be 4 pi over 6. We can leave 5 pi over 6 alone, and then pi is going to become 6 pi over 6. We're ready now to do our expected y values. We know that we are graphing y equals negative sine of 3 times x minus pi over 3 plus a negative 2 or minus 2. We can write it either way. So it is a sine graph, and we know that the expected values for sine are 0, 1, 0, negative 1, and 0. Now the y values will be affected by letter A and D. And looking at our function here, A is equal to negative 1. Remember, you use A here. You don't use amplitude, which is the absolute value of negative 1. We use actually A here, so we use the negative sign there. And we know that D is equal to negative 2. So those two values will affect the y values of the graph. We have to take every one of our y values and multiply it times negative 1 and then subtract 2. So we get 0 minus 2 is negative 2. We get negative 1 minus 2 is negative 3. 0 minus 2, negative 2. Negative 1 times negative 1 is positive 1. Minus 2 is negative 1. And 0 minus 2 is negative 2. We're ready now to check our values, and I'll check both of these just in case whichever one you checked, you'll be able to look at the work for it. So if we check the quarter point here, we can plug in 3 pi over 6, or we can plug in pi over 2. It doesn't matter which version. We're going to have to get a common denominator here, so maybe I'll go ahead and use the 3 pi over 6. So we're going to have negative sine of 3 times 3 pi over 6 minus pi over 3, but I'm going to write that as 2 pi over 6. And then plus a negative 2. So 3 pi over 6 minus 2 pi over 6 will be 1 pi over 6. This will be pi over 6, which we have to then take times 3. So 3 times pi over 6 is pi over 2. So that argument there is going to turn into pi over 2. So this becomes negative sine of pi over 2 minus 2. We know that the sine of pi over 2 is 1. So this becomes negative 1 minus 2, which is equal to negative 3. And that checks out with what we expected. If you chose to check this value, because remember, we don't use the ones that were the roots because you could have your graph upside down and you wouldn't catch it. You always want to use the min and the max. So if we plug in 5 pi over 6 up here for x, we're going to have negative sine of 3 times 5 pi over 6 minus the pi over 3, which I'll write again as 2 pi over 6, and then plus a negative 2, I'm going to write as minus 2. Now looking at these two fractions, 5 pi over 6 minus 2 pi over 6 is going to be 3 pi over 6, which of course is pi over 2, and we have to multiply that times 3, so this is going to become negative sine of 3 pi over 2 minus 2. We know we've got negative. Now the sine of 3 pi over 2 is negative 1, and then minus 2. Of course, the opposite of negative 1 is positive 1. 1 minus 2 is negative 1. So that one worked out as well. Now we're ready to go ahead and plot our points and see what our graph is going to look like. Now, our x values all have a denominator of 6, so we're going to want our x scale to be pi over 6. So we start with 1 pi over 6, then 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. Now notice we couldn't begin with 2 pi over 6, because if I put a 2 pi over 6 here and a 3 pi over 6 here, then my x scale would be inconsistent, because the distance from here to here would have been 2 pi over 6, but the distance from here to here would have been 1 pi over 6. So even though we're not plotting this point, we have to have a consistent x scale where every dotted line goes up by the same amount. In the y direction, looks like we can go by ones here. All our y values are negative, so we don't need to put anything on the positive y-axis. We'll just label these on the negative y-axis, and we're ready to plot our graph. Our first point is 2 pi over 6, negative 2. Next, we have 3 pi over 6, negative 3. 4 pi over 6, negative 2. 5 pi over 6, negative 1. And 6 pi over 6, negative 2. We connect all the points with smooth curves. And there's our graph. Now we can go ahead and check with all the attributes that we expected from the beginning. We expected the period to be 2 pi over 3, and you want to verify that on your graph. We know 6 pi over 6 minus 2 pi over 6 is 4 pi over 6, which is 2 pi over 3. The amplitude needs to be 1, so if we go from the center line down to a minimum, we see that distance is 1, or from the center line up to a maximum, that distance is 1, so the amplitude checks out. The phase shift needed to be pi over 3 to the right, and we know that normally sine will start out not here, but over here on the y-axis. So this point shifted over by 2 pi over 6, which if we reduce is pi over 3. So that checks out. The vertical shift we expected to be down by 2, so this center line of the graph should have been the x-axis, but we can see it moved down to negative 2, which means we had a downward shift by 2. We expected the range to be negative 3 to negative 1, and our smallest y value is negative 3. Our largest y value is negative 1, so that worked out. And we also know that because we had a negative out front, we expected the graph to be flipped over. So instead of going root max, root min, root, we expect that it would go root min, root max, root, because it would be flipped over. So we were successful.